Welcome to Edino's practical session of resistance of galvanometer. In this session, we will determine the resistance of galvanometer by off deflection method and then we will find its figure of merit. Before going to the experiment, let us see what is galvanometer and its figure of merit.
Galvanometer. A galvanometer is a device used for detecting weak or feeble currents in the electric circuits. It consists of a horseshoe magnet with concave pole to provide a radial magnetic field. A copper frame wrapped with a thin insulated copper wire acts as a coil. It is mounted between the poles of the horseshoe magnet. Two hairsprings are attached to control the motion of the coil. These two hairsprings are in contact with the two terminals of the galvanometer. An aluminum pointer is attached perpendicular to the coil, which move over an arc scale. The scale has 0 in the middle and equal number of divisions on either side. As current passes through the circuit, you can see the deflection in the pointer. If we reverse the direction of the current, the pointer deflects on the other side of the scale. Here, the deflection is proportional to the current passing through the galvanometer. When the current passes through the coil, it experiences two equal, parallel and opposite forces on it. These forces form a couple and rotate the coil, and in turn make the pointer to deflect in proportion to the current passing through the galvanometer. To find out the figure of merit, we connect the galvanometer as per the circuit. Here, the current required to produce one division of deflection in the scale of galvanometer is known as figure of merit, which is represented by K. K is equal to I by theta. We know I is equal to V by R. Therefore, K is equal to E by R plus G into theta, where E is equal to EMF of the cell, R is equal to resistance connected in series, G is equal to galvanometer resistance, theta is equal to deflection in the galvanometer.
Hope you understood the concept of galvanometer and its figure of merit. Now, let us go through the aim and apparatus required to perform this experiment.
The aim of this experiment is to determine resistance of galvanometer by half deflection method and to find its figure of merit. The apparatus used in this experiment are a Western type galvanometer, a voltmeter of range 0 to 3 volts, a battery eliminator, two one-way keys, a rheostat, a screw gauge, half meter scale, and milliammeter of range 0 to 50 amps, and connecting wires. Resistance of galvanometer. To find the resistance of a galvanometer by half deflection method, we connect the galvanometer in the circuit as shown here. Here, when you close the key K1, the current passing through the galvanometer is given by I is equal to E divided by R plus G, which is K theta, where E is equal to EMF of the cell, R is the resistance, G is equal to galvanometer resistance, theta is the deflection, K is equal to constant. Now, close the key K2 and adjust the shunt resistance S such that the deflection in the galvanometer is theta by 2, which is half of the previous deflection. The resistance of parallel combination of G and S is given by Gs divided by G plus S, and the current in the circuit is Ig, and the fraction of current passing through the galvanometer is I minus Ig. So, by comparing the equations 1 and 3 and by solving equation 4, we get the galvanometer resistance G is equal to R into S by R plus S.
Well, let us move to the step-by-step procedure to perform the experiment. First and foremost, we will determine the resistance of the galvanometer. To do so, we need to arrange and connect the apparatus as per the circuit diagram. First, we connect the positive terminal of the power supply to one end of the resistance box. Then, from the other end of the resistance box to one end of the galvanometer. After that, from the other end of the galvanometer to the plug key. And then from the other end of the plug key to the negative terminal of the power supply. Now, as per the circuit diagram, we need to connect a resistance box and a plug key in parallel to the galvanometer. So, let us connect. Here, one end of the galvanometer is connected to the plug key. Then, from the other end of the plug key to one end of the resistance box. And finally, from the other end of the resistance box to the other end of the galvanometer. Here, we have completed the connections as per the circuit diagram. Now, let me summarize the connections for you. Here, the positive terminal of the power supply is connected to one end of the resistance box, and the other end of the resistance box is connected to one end of the galvanometer, and the other end of the galvanometer is connected to one end of the plug key, and the other end of the plug key is connected to the negative terminal of the power supply. Here, this resistance box is connected in series with the galvanometer, and this plug key helps us to allow the current to pass through the circuit. Also, Another resistance box is connected in parallel with galvanometer along with this key. After completing the connections, let us take first set of observations. Switch on the power supply and introduce some high resistance in the series resistance box, and then put in the plug key so that current flows through the circuit. Here you can see that galvanometer showing some deflection, which means that current is flowing through the circuit. Now adjust the series resistance in such a way that a deflection with even number of divisions is obtained in the galvanometer. So let us adjust the series resistance. Here you can see that the galvanometer is showing a deflection of 28 divisions for a series resistance of 3200 ohm. Now we introduce the parallel resistance by closing the key in the parallel circuit. After that, we adjust the parallel resistance until deflection in the galvanometer is half of the previous deflection. So let us adjust the parallel resistance. Here you can see that the deflection in the galvanometer is 14 divisions for a parallel resistance of 47 ohms. Note these values in the observation table. After that, knowing the values of series and parallel resistance, we can calculate the resistance of the galvanometer.
Series resistance R is equal to 3200 ohms. Deflection in the galvanometer is equal to 28. Shunt resistance S is equal to 47 ohms. Half deflection theta by 2 is equal to 14. Galvanometer resistance G is equal to Rs divided by R minus S, that is 3200 into 47 by 3200 minus 47, which is 47.70 ohms.
Now we got one set of observations. For more observations, we repeat the same procedure for different values of deflections in the galvanometer, and in each case we find the resistance of the galvanometer. Then we take the mean resistance as the resistance of the galvanometer.
For a series resistance of 3200 ohms, the deflection of the galvanometer is 28 and the corresponding shunt resistance in the half deflection is 47 ohms. galvanometer resistance is calculated by G is equal to Rs divided by R minus S, that is equal to 3200 into 47 by 3200 minus 47, which is 47.70 ohms. Similarly, the values for a series resistance of 5050 ohms and 8200 ohms are as follows. Mean value of galvanometer resistance is G is equal to G1 plus G2 plus G3 by 3, which is 47.80 ohms.
After determining the resistance of the galvanometer, let us move on to find its figure of merit. Figure of merit is nothing but the current required to produce unit deflection in the galvanometer. Here, for finding the figure of merit, parallel resistance is not required in the circuit. So let us remove the parallel resistance. Here you can see that the connections are as per the circuit diagram for the determination of figure of merit. First and foremost, we need to measure the potential difference across the terminals of the power supply. To do so, take a voltmeter, connect positive terminal of the voltmeter to the positive terminal of the power supply. And negative terminal of the voltmeter to the negative terminal of the power supply. Now switch on the power supply. Here you can see that the voltmeter is showing a reading of 2.5 volts. That means the potential difference across the terminals of the circuit is 2.5 volts. Note this value in the observation table. After that, introduce some resistance in the circuit. Then close the key so that current flows through the circuit. Here you can see that the galvanometer is showing a deflection of 20 divisions for a resistance of 5000 ohm. Note these values in the observation table. Knowing the values of potential difference V, series resistance R, resistance of galvanometer G and galvanometer deflection theta, we calculate the figure of merit K.
E is equal to EMF of the cell, which is 2.5 volts. R is equal to resistance in series, that is 5000 ohms. G is equal to galvanometer resistance, that is 47.80 ohms. Theta is equal to deflection produced, that is 20. K is equal to E by R plus G into theta, which is 2.5 divided by 5000 plus 47.80 into 20, that is 0.00002476.
Similarly, we repeat the same procedure for different values of potential difference, and in each case we calculate the figure of merit. Then we take the mean value as the figure of merit of the galvanometer.
For a 2.5 volt EMF of the battery, the resistance introduced is 5000 ohms and deflection observed is 20. Therefore, the figure of merit K is equal to E by R plus G into theta. That is 2.5 divided by 5000 plus 47.80 into 20, which is 0.00002476. Similarly, for 5 and 7.5 volts EMF of the battery, the values are as follows. Mean value of the figure of merit K is equal to K1 plus K2 plus K3 by 3. Therefore, K is equal to 0.00002446. The connections should be neat, clean and tight. All the plugs in the resistance box should be keyed properly. The cell should have a constant EMF all through the experiment. Initially, a high resistance from a resistance box R should be introduced in the circuit to avoid any damage to the galvanometer. The value of R must be very large as compared to the value of G.
Now you are able to determine the resistance and figure of merit of any galvanometer on your own without any doubt or hesitation. Thank you for watching this video.